Alright, silly people, here's the situation. This equation, which is a superposition of um, exponentials with constants tacked onto them, uh, and this equation is a similar sort of thing where you have a cosine and a sine with appropriate constants tacked onto them. Uh, and I'm going to tell you that these two equations are representing the same sort of thing. Um, and there's a relationship between the constants A, B, C, and D um, where they match up. So um, to do this, first of all, we're going to work on the left-hand side using Euler's identity, which is e to the I z is equal to cosine z plus I sine z, and if there's a minus sign up in the exponential, the minus sign becomes manifest in the sign of the sine function. So I'll just write like that. So using that, we have that it's a times cosine kx plus I sine kx plus b cosine kx minus I sine kx, and the right hand side is the same. We're not really doing anything with it. We can group them together based on trig functions rather than on a and b. So we'll get cosine kx, and then we'll group together everything like that. So it's going to be a plus b for that. And then we also have stuff that is proportional to the sine of kx, and that's going to be ai. So ia minus ib, and that's equal to the stuff on the right hand side. And now we can just compare the left hand side and the right hand side and notice that a plus b is equal to c, and also ia minus ib is just equal to d, and we'll leave it like that. You can do a similar thing going from the right hand side to the left if instead you make use of the exponential forms of the trig functions, which is given by cosine z is e to the iz plus e to the minus iz over 2, and sine will be given by e to the iz minus e to the minus iz over 2i. So going back up top and plugging those identities on the right hand side of the equation, we have that ai kx plus b e to the minus I kx is equal to c times e to the I kx plus e to the minus I kx, not z, kx over 2, plus d times e to the I kx minus e to the minus I kx over 2i. And now we can group things together on the right hand side by exponentials. So I have e to the I kx, and then we have a c over 2 plus a d over 2 I. That's it. And then we also have a e to the minus I kx, and that's c over 2 minus d over 2i. And then we can do a similar sort of thing where we see that a is just equal to c over 2 plus d over 2I, and then b will be c over 2 minus d over 2I. I'm not going to show it, but these relations are identical to these relations that we just found. I'll leave that as an exercise to the watcher. But yeah, those equations are the same thing. The constants are related thusly. All right.